My name is Madison Nava, and I will be discussing mitochondrial DNA and Y-STRs in forensic cases. Y-STRs are male specific, meaning that it is only a paternal lineage as the Y chromosome is unique to males. As you can see in the right-hand side image, females will have two X chromosomes, while males will have X and Y chromosome. Why is this useful in forensic science? This is useful to determine if more than one male has contributed to a mixture, as well as it's beneficial for mixtures that have high levels of female DNA and low levels of male DNA. This is typically useful in alleged sexual assault cases, paternity testing, and missing persons per Lies Forensic Biology textbook. Mitochondrial DNA is maternally inherited. So, a relative within the same maternal lineage has an identical mitochondrial DNA sequence, meaning that the relative can provide a reference sample. So, this same thing applies for Y-STRs, but on the paternal side. So, what makes mitochondrial DNA useful for forensic science? So, it is useful for old items of evidence that are associated with cold cases, as well as small pieces of evidence containing little biological evidence. What evidence types are typically best for mitochondrial DNA analysis? This includes hair shafts, buried bones, and decomposed tissues. Hair shafts will be discussed later in the presentation. All in all, mitochondrial DNA analysis is useful for human identification, such as identifying victims of missing persons and individuals in mass fatality cases, as mentioned in Lie's Forensic Biology textbook. So let's talk about a specific case that involves this. So on March 12th, 1995, a missing person report was made by Kathleen Leonard's employer, as she had several absences and was unable to be contacted by phone. This is stated in Magaletti versus State. The same day, her decomposed body was discovered in her Florida apartment, where investigators found her fully clothed and lying face down on her bed. In addition to that, torn towels were used to strangle her and to bind her hands behind her back. There was no sign of forced entry. Joseph Magaletti was arrested in 1999. He was her neighbor. His fingerprints were found on the inside of the victim's door beneath the doorknob. In addition to that, they collected many strands of hair that were found on the towels. They did hair comparison and mitochondrial DNA analysis that identified Magaletti as the donor of a single hair per Keller. So let's briefly talk about who is Joseph Magaletti. So he was a drug abuser and he didn't keep jobs for very long. He would steal from department stores and then he would sell those items to earn money to pay for drugs. He was suspected of additional killings besides this one, but this of course wasn't proved. But what was his potential motive? They suspected, as in the investigators suspected, that he may have been wanting to steal items that he could sell to help pay for his drugs. When they found Kathleen Leonard, the contents of her purse had been emptied, leaving credit cards, but no cash and nothing else, but nothing else was stolen. So Mitochondrial, as I mentioned, mitochondrial DNA analysis was used in this case. So before we talk about that, why was traditional STR analysis not helpful for this case? So as I mentioned, they had a strand of hair, and they had, to be specific, they had the shaft of a strand of hair. Nuclear DNA is only present in the hair follicle, and the hair follicle contains high amount of DNA for traditional STR analysis. So this makes sense, as you can see in the right hand side image. The shaft is not directly connected to the body compared to the follicle. So STR analysis was not helpful for this case because they did not have a hair follicle, which I will mention again in the next slide. But essentially, samples that contain low amounts or degraded nuclear DNA, such as hair shafts or buried bones, will not give successful results using traditional STR analysis. Rootless hair shafts, they are really challenging for analysis, which is why traditional STR analysis is typically not um, a good route to take. So let's talk about mitochondrial DNA analysis used in this case. So this case was first a cold case before it got solved. Their technology was not advanced enough when the murder did occur. The investigator suspected that Magaletti committed the crime, but they couldn't really prove it. Recoverability. So mitochondrial DNA has greater copy numbers and an additional mitochondrial membrane, as Gutierrez mentions. This membrane protects the genetic material from degrading. So mitochondrial DNA is beneficial for samples that have low amounts or degraded nuclear DNA. Mitochondrial DNA can take smaller samples and small amounts of mitochondrial DNA, as mentioned in Magaletti versus State. So this is useful in cases where there is no root or follicle tissue, such as this case, where they only had the shaft. So what was the outcome of this case? So he was finally convicted on June 15th, 2001 for first degree murder. The admissibility of mitochondrial DNA was argued, but a Fry hearing established that mitochondrial DNA analysis, as well as the statistical calculation used, was generally accepted by forensic scientists throughout the country, as mentioned in Magaletti versus State. The counting method was used and a 95% confidence interval was applied. So this proved that 99.93% of people randomly selected would not match the unknown hair sample that was found at the crime scene. Magaletti did die in prison in 2015. After this occurred, Touch DNA linked him to Denise Stafford's murder. And like I said, they also suspect that there was additional killings, but there's nothing to prove and they don't have any at the moment. Thank you.